Hey YouTube, this is diveflyfish. Just want to show you another experiment that I'm going to be doing. I have a piece of the magnesium that I've treated with the oxide layer. I've taken the graphite and I've rubbed it into the oxide layer here, and here I just have the plain oxide layer. I have 4 identical pieces of carbon that I'm using as an electrolyte. I'm going to be utilizing isopropyl alcohol 70% here, water here, isopropyl alcohol 70% here, and water here. We're just going to show what the differential in voltages show. So I'm just going to place a small volume of water on the area of the electrode where we're going to have that, and then a small amount of water here on the graphite there. And I'm going to do the exact same thing with the isopropyl and the isopropyl here. Okay, so all things being equal, let's see what these voltages show. So I'm going to take the first one. I'll just place this piece of carbon here. 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 And let's see what the voltages are. Okay? So we'll start with the water on the magnesium, and let's see what it shows. Okay, 1.9. Okay. Take the ethanol, 1.8. Okay, that's on the oxide. So the water has a little bit more water in it than the ethanol at only 30%. So we see that voltage differential. Now we have the graphite with the water on the oxide, 1.81, okay. And now with the ethanol, 1.95. So it's interesting, the effect, pardon my cat, just got in the middle of the video, so let's check that again. So make sure that everything is wet where it needs to be. Okay, so let's try this again. So we have the ethanol here at 1.934, the water in graphite 1.82, the ethanol, carbon, and just the oxide layer at 1.84, and the water on the magnesium oxide electrolyte at 1.8, 1.9. So the best seemingly effect is to have the ethanol with graphite, so a lower percentage of water. So it may not be overall the amount of water that's there, but just actually the surface interface itself. So again, we're seeing, definitely differentials in voltages and with otherwise identical electrodes and otherwise identical substrates, varying percentages of water and how these things are functioning. So again, the best performer seems to be the water on the bare oxide with carbon, as well as the ethanol on the carbon here. Again, we'll just double check that one more time. Let me make sure the electrode's in the right position. So here again we should have about 1.9, yep, 1.8, 1.8, and this should be about 1.9 again. Now what I'm going to do is I'm going to switch this over to the milliamp hour amount, and let's see what kind of current flow we have out of this, if at all. So we have on the water and oxide we have about 3.6 or 3.3. Put that back over there. The ethanol, much less. Water, 10 with the graphite, and then the ethanol. So current level is mostly affected by water, voltage not so much, but the amount of current flow, and that could be also part and parcel to the fact that this may be drying out, so I'll just rehydrate that with the ethanol a little bit on these two spots to see if that's part of it. But again, it's only 30% water in that isopropyl mix. So that being said, let's see what shows with that being rehydrated now. No, again, the milliamp hour with alcohol is quite poor. So at least with the functionality of these cells, excuse me, the functionality of these cells with current flow is directly seemingly proportional to the amount of water that is present. But again, the good news is that with this oxide layer, it may not at all be in a detrimental kind of way, oops, wrong way, as far as what these things will be producing. but the carbon does seem to be advantageous as an interface on the oxide layer versus just plain, from what I'm seeing here. Okay, so for what it's worth, thanks for watching. Have a great night.